Hello there, AP Calc students. This is lesson 5-3, definite integrals and antiderivatives. Now this first frame here might seem a little daunting. These are rules for definite integrals, as you can see. I believe this is pretty much the exact same thing that's in your textbook, so if you have a hard time seeing this, you can just copy these from your textbook. We'll be working on these in class in our peer reviews and stuff, and I think it will make more sense, and most of them are pretty intuitive or common sense. Just remember that anytime you have a integral like this, it's an area. So if that's why something like this makes sense, because if you have an integral from a to a, in other words, if you thought about it, it would be just a vertical line. That has no area. That's why that's 0. And if you think about these in terms of area, sometimes we could draw a little picture of each of these, and then I think it would make more sense. Really, I'd say the first 5 here are probably the most important. I don't think we'll use 6 and 7 too much. So again, take some time to copy these down, or maybe later on if you want to look at them. They are in lesson 5.3 in your book. Alright, here's a couple other little theorems or definitions that we'll work with today. The average mean value. And again, if we just think about what average means, we know that that's a math term that you've used for many years, where you add up all the numbers and divide by how many there are to get the average. Well, we could actually get an average value for an integral, believe it or not, and it works like this. Again, here's our integral. Whatever this particular function is from a to b, remember an integral is an area under a curve. What's the average value of that integral between these 2 points? Well, it says to take this integral and multiply it by 1 over b minus a. Again, b minus a would be your x value, so to speak. So let's look at an example of how this might work. We'd like to find the average value of f of x equals x squared on that interval 0 to 4. And does f actually take on this value at some point in the given interval? So I already did the integral of x squared from 0 to 4. Remember, you can do that on your calculator pretty nicely, and here it is. Notice it's about 21 1/3. So let's just see if this formula works. So according to this now, I should be able to take 1 over, and it's from 0 to 4, so it's going to be 4 minus 0. I'm going to actually put in those values for a and b here as well, from 0 to 4. And then my function in this case is x squared dx. Well, of course I get 1/4, and I did figure out that that actual value of this integral here, remember, is 21 1/3. Now 21 1/3 is the same as 64 thirds, I believe, if I write that as an improper fraction. And I'm going to change pen colors here. I'm going to do a little reducing. So if I divide that by 4 and this by 4, I get 16. And so my final answer then ends up to be 16 thirds, which is about 5 1/3. Okay? So what that means now is that this x squared here, that's my actual function, if that equals 16 thirds, we'd like to know if that particular x value is really in this interval. Well, just to solve this for x, of course, I would take the square root of 16 thirds. And when I take a square root, I have to put a plus or minus in front of that, of course. And so I would get 4 over the square root of 3 plus or minus that, of course. And if I figure out what that is approximately decimal-wise, it's about plus or minus 2.3. And is that in the interval? Well, the negative part isn't, but certainly positive 2.3. Positive 2.3 is certainly in this interval here between 0 and 4. So yeah, that function actually does take on that value someplace in that interval. So average mean value, just another way of looking at integrals. Alright, one last slide here, the mean value theorem for integrals. So let's take a look at that. Again, we have to have a continuous function and it says some point, we're again looking for some point C. You might remember we did a problem like this last unit with derivatives, that mean value theorem for derivatives. This is for integrals. Now, interestingly enough here, if I rewrite this thing, and if I multiply this b minus a on both sides, notice that I will get b minus a times the f of c, and then that's going to actually equal my integral here, f of x dx. Now what this theorem is really saying, if we think about it a bit, remember this is our integral, that's our area under the curve, so it would be this whole area here from a to b. Now notice when I multiply both sides by this b minus a, in a sense here this becomes the width, or the base, I'm going to call it, of a rectangle, and f of c, of course, that's like your y value, so that would be your height. So if we look at it in here, what this theorem is saying is, yeah, this actual area here of the integral is going to be the same as the area of some rectangle here. Notice here's my b minus a, here's that f of c, so base times height, the area of that rectangle, and we should be able to find some point c in that interval, which would give me that rectangle, the height of that rectangle, which would have the same area as this. So that's kind of cool, I think. Maybe you don't think so, but it's kind of interesting, I believe. Now let's just do a quick example here, see if we could show that this is true. The function we're going to look at is x cubed. So we want f of x to be x cubed, and we want to look at it between 2 and 4. Okay? And I'm just going to write it like this. So my interval is from 2 to 4, like that. Okay? So according to this theorem now, I'm going to have 1 over b minus a. Actually, I'm going to maybe write it already kind of like this. So I'm going to take my b minus a times that f of c there. So writing it like that, I get 4 minus 2, and then that f of c, of course I don't really know what that is yet, and that's going to equal my definite integral. Remember I said from 2 to 4, and it's x cubed dx. Well, I went on the calculator and figured out what this is, x cubed between 2 and 4, and sure enough I got a total area for that of 60. 4 minus 2, of course, is 2, so 2 times the f of c is going to be 60. Of course, then that means that that f of c must be 30. Now, the f of c, it just means that I put c in place of the original function here. So I think you see probably that the f of c, I'll change colors here just for emphasis. So that will be then c to the third power, that's the function, was x cubed, so c to the third equals 30. And if I take the cube root of each side, c is going to be the cube root of 30. And sure enough, that is about 3.1. And is 3.1 a number that's in that interval? Yeah, it sure is, because this is in the interval 2, 4. So, again, just kind of fun with integrals here as we show that this mean value theorem works. So that's about it for this video, gang. We'll be working, as I said, on those properties of integrals when we get to class. So thank you very much for watching, and we'll see you then.